Hi, thanks a lot for listening to this tutorial, the tutorial on the introduction of statistical hypothesis testing. In this tutorial video, we will show you what are the fundamental principles of hypothesis testing, and after studying the different basis of this notion, we will show you how to practically implement a hypothesis testing in practice. So let's start with general definition and goal of hypothesis testing. So the general goal of the hypothesis test is to rule out chance sampling error as a plausible explanation for the result from a research study. So in the research study, we can search if whether or not a plausible explanation for the result is just due to sampling. So hypothesis test is a technique to help determine whether a specific action has an effect on the individual in a population. So you make an action, and after the action is made in the population, you try to find out if the action have effect or not through hypothesis testing. So the hypothesis test is used to evaluate the result from the research study in which a sample is selected from a population, first of all, and secondly, an action or a treatment is administered to the sample, and thirdly, after action or a treatment, for example, the individuals in the sample are measured. So hypothesis testing after this measure will help you set a decision on whether or not the action that have been made have an effect or not. So you can see an unknown population before a treatment that have a standard deviation of 20, and the mean of the population is equal to 80. And after treatment we have the same standard deviation, and the mean of the population is calculated, and hypothesis testing will make a decision of whether or not a treatment have an action based on the value of the mean of the population after treatment, based on hypothesis testing principle that we will show you a little bit sooner in this tutorial video. So if the individual in the sample have a noticeable difference from the individual in the original population, we have evidence that the action made has an effect. So how to measure this effect using hypothesis testing, statistical hypothesis testing will show you in this tutorial video. How it is also possible that the difference between the sample and the population is simply sampling error. We'll answer this question for the end of this tutorial video. So we can also once more illustrate the unknown original population of mean 80 in our sample, and after administration of the treatment we have also the mean of the population that we will use determine whether or not we can accept that the the treatment have an effect on our population, on our sample, of our sample population. So the purpose of the hypothesis test is to decide between two explanations. First, the difference between the sample and the population can be explained by sampling error. There does not appear to be an action effect. So, thirdly, the difference between the sample and the population is too large to be explained by sampling error. There does appear to be the action effect. So, this illustration show you a distribution of mean of our population, and we in the hypothesis test it will be necessary to search to use extreme low probability value if H0 is true. So the distribution of the sample mean is, if the null hypothesis is true, is shown in this graph in front of you. So after computing the extreme low probability values, that can be that we call in hypothesis testing a threshold. After computing this extreme low probability value according to the set threshold, we will take the decision using critical region that we will explain to you what it is in this tutorial a little bit sooner. So what is the null hypothesis in hypothesis test? What is alpha level? What is critical region? And the test statistic. So the following four-step outline process of hypothesis testing and introduce some of the new terminology in hypothesis test that we'll be using in order to set a decision of whether or not to reject or accept the null hypothesis. So the first step in hypothesis test is to set the hypothesis and select an alpha level. The null hypothesis H0 always states that the action or treatment has not effect. So the action or the treatment that we made on our sample has not effect. So they do not change or they do not differentiate the mean of our sample. And according to the null hypothesis, the population means after treatment is the same it was before treatment. So that's what mean null hypothesis. The alpha level establishes the criterion or cutoff for making a decision about the null hypothesis. The alpha level also determines the risk of type 1, the risk of type 1 error. So we'll come back on the risk types in this tutorial video. So taking a normal distribution probability, we can set the different low probability level for the threshold of 5%. 5%, threshold of 0.05. That's the critical value that set the alpha equal 5% level. So that means that when we compute, if on the null hypothesis our variable follow a normal law of mean 0 and standard deviation 1, we will reject the null hypothesis when our test statistic will be superior to 1.96. So we'll come back a little bit earlier sooner in this notion. We also have 1% low probability level of 1%, which is 2.58 for the normal distribution of mean 0 and standard deviation 1, and so on. So the step 2 in hypothesis testing is to locate the critical region. The critical region consists of outcomes that are very unlikely to occur if the null hypothesis is true. That is, the critical region of is defined by sample mean that are mostly important to obtain if the action or a treatment has not effect. The phrase almost impossible means that these samples have a probability p that is less than the alpha level. So we have, in the case of normal distribution, a representation of critical region that is the region that is painted in blue. So we have for the normal distribution of mean 0 and standard deviation 1.95% low probability level for a threshold of 0.5%. So middle 95% high probability value if H0 is true. So the probability that the mean of our sample is being equal to 18 is when is equal to the probability that the mean of our sample is superior to 40 that the standard deviation of our sample is superior to 1.95 is 0.5%. That is the probability that is located in the critical region. So the step 3 is to compute the test statistic. The test statistic forms a ratio comparing the obtained difference between the sample mean and the hypothesized population mean versus the amount of difference we would expect without any treatment or any treatment effect, the standard error. So the last step in the hypothesis test is to that a large value for the test statistic show that the obtained mean difference is more than would be expected if there is no treatment effect. If it is large enough to be in the critical region, we conclude that the difference is significant or that the treatment has a significant effect. In this case, we reject the null hypothesis. If the mean difference is relatively small, then the test statistic will have a low value. In this case, we conclude that the evidence from the sample is not sufficient and the decision is fair to reject the null hypothesis. So you have an illustration of the population, for example, without alcohol, which have mean of 80, normal distribution with standard deviation 4. We have a sample of 16 persons. So we also have a population with alcohol. We have the mean on that normal distribution and the standard deviation of 4. The null hypothesis in this case is that the alcohol has not effect. The mean is still 80. We will test this hypothesis. What is error in statistic in hypothesis test? So just because the sample mean is different from the original population mean does not necessarily indicate that the treatment has caused a change. You should recall that there usually is some discrepancy between the sample means and the population mean simply as a result of sampling errors. So because the hypothesis test rely on a sample data and because sample data are not completely reliable, there's always the risk that misleading data will cause the hypothesis test to reach a wrong conclusion. So two types of error are possible. Error type 1 Type 1 errors occur when the sample data appear to show the treatment effect when in fact there is none. In this case, the researcher will reject the null hypothesis and falsely conclude that the treatment has an effect. Type 1 error is caused by usually unrepresentative samples. Just by chance, the researchers select an extreme sample with the result that the sample falls into critical region when the treatment has not effect. The hypothesis test is structured so that type 1 error are very unlikely. Specifically, the probability of the type 1 error is equal to the alpha level. So another type of error is type 2 error, which occur when the sample does not appear to have been affected by the treatment when, and in fact, the treatment does have an effect. In this case, the researcher will fail to reject the null hypothesis and falsely conclude that the treatment does not have an effect. The type 2 error are commonly the result of the very small treatment effect. Although the treatment does have an effect, it is not large enough to show up in the research study. So we can illustrate the two types of errors in this table. So we have type 1 error is the probability to reject H0 while H0 where there is not effect. So when which means when H0 is true, and type 2 error is the probability to retain H0 while H0 is false. So in two other cases we have correct decision. So we also have directional tests. When the research study predict a specific direction for the treatment effect, increase or decrease, it is possible to incorporate the directional prediction into the hypothesis test. The result is called a directional test or a one-tailed test. A directional test includes the directional prediction in the statement of the hypothesis and in the location of the critical region. For example, in the original population, if the original population have a mean of mu equal 80 and the treatment is predicted to increase the score, then the null hypothesis will state that after treatment 80 is less than 80, there is no decrease. In this case, the entire critical region will be located in the right-hand tail, of the distribution, because large value for m will demonstrate that there is an increase and will tend to project the null hypothesis. So in hypothesis test, we also have to measure effect size. So what is measuring effect size? A hypothesis test evaluates the critical significance of the result from the research study. That is, the test determine whether or not it is likely that the obtained sample mean occur without any contribution from the treatment effect. The hypothesis test is influenced not only by the size of the treatment effect, but also by the size of the sample. Thus, even a very small effect can be significant if it is observed in a very large sample. Because a significant effect does not necessarily mean a large effect, it is recommended that the hypothesis test be accompanied by the measure of the effect size. We use coherent standard deviation as a standardized measure of effect size, much like z-score. Cohen standard deviation measures the size of the mean difference in terms of the standard deviation. So we have the two representation distribution of SAT score before treatment, and we also have a distribution after the treatment. We have an increase of 15 in the mean of the sample. So we have also the distribution of the interquartile score before treatment and after the treatment. That can be used to measure the size effect of our population. So we also have the power of the hypothesis test. The power of the hypothesis test is defined as the probability that the test will reject the null hypothesis when the treatment does have an effect. So the power of the test depends on the variety of factors during the size of the treatment effect and the size of the sample. So we can illustrate the power of the hypothesis test using our original population with normal with a standard deviation of 40 and a mean of 10. So if H0 is true, H0 equal 40 and standard deviation equal 10. With 8-point treatment effect, we have a mean of 88 and standard deviation which remain 10. The distribution of sample mean for n equal 25 if H0 is true. We have also a distribution of a sample mean for the same 25 with 8-point effect. So in this situation, we have a rejection region of the null hypothesis test. So we will delve now into our practical case to illustrate practically what we have learned in this tutorial video. So we'll take example of Templer and Tomeo in 2002 that reported that the population mean score on the quantitative portion of the graduate record examination general test for students taking the exam between 1994 and 1997 was 558 with standard deviation of 139. Suppose we select a sample of 100 participants. We record a sample mean equal to 585. So we compute one independent sample test for whether or not we will return the null hypothesis m equal 558 at 5% of significance level. So the step one, as we show you earlier, is that we need to state the hypothesis. So the population mean is 555, and we are testing whether or not the hypothesis test is the hypothesis is equal or is not equal or correct. H0 is so m equal 555, mean test score are equal to 552 in the population. H1, which is the alternative hypothesis, is that mean is different to 558, means test score are not equal to 558 in the population. So in the step 2, we set the criteria for the decision. The level of significance is 5%, which make the alpha level of 5%. To locate the probability of obtaining the sample mean from the given population, we use the standard normal distribution. We locate the z-score of the standard normal distribution that are the cutoff or critical value for sample mean value with less than 5% probability of occurrence if the value state in the null m equal 558 is true. So in the step 3, we compute the test statistic. So we can notice that step 2 set the stage for making a decision because the criterion is set. The probability is less than 5% that we will obtain a sample mean that is the least, that is at least 1.96 standard deviation above or below the value of the population mean stated in the null hypothesis. In this step, we will compute the test statistic to determine whether the sample mean we selected is beyond or within the critical value we state in step 2. The Z statistic formula is the sample mean minus the population mean stated in the null hypothesis divided by the standard error of the mean. So we write the formula mean minus mean of the population under the null hypothesis divided by the standard deviation of the population, which the standard deviation is given by the of the sample is given by the standard deviation of the population divided by the square root of the sample. So our calculated standard deviation is 13.9. So the z-score is, as we said, the mean minus the population mean stated in the null hypothesis divided by the standard error in the mean of the mean. So we find out that the test statistic is 1.94. But what we in the last step of the test, we need to make a decision. To make a decision, we compare the obtained value of the critical value We reject the null hypothesis if the obtained value exceed the critical region. Figures show that the obtained value is 1.94, is less than the critical values, which is set as at 1.96. It does not fall into rejection region. So the decision is to obtain the null, to return the null hypothesis, which means that the obtained value of 1.94, which failed to reach the cutoff for the rejection region, so we return the null hypothesis, which means that in our sample population, the mean does not increase or does not change in our sample. So that's it for this tutorial, and we hope it helped you understand your notion of of hypothesis test, and we will see you a little bit sooner in other tutorial video. Thank you.